Can you all see and hear me?
Yes.
Yeah, okay. Hold on for a sec. Hold on. Let's see, right there. Okay, so my question was under what condition does the free cash flow model yield the same result as the equation free cash flow 1 divided by WACC minus G? So first off, I think it would be a good thing to break the free cash flow model in two. So the first part of the equation is the one we all familiar with. It's the present value of the discounted cash flow, which is not really relevant for that particular question. But what's more interesting is the second part of the equation. If we only take in consideration the first, the numerator, here we can already see that is really closely familiar to that one. And so on the kind of yellowish color here, it's a continuous value of the free cash flow, which is the free cash flow of year one of the continuous value divided by WACC minus G. Oh, and for the record, sorry, because the picture is on here for me, but for all those exercise, I took, I think the WACC is 5 point, can you see it? Because I can, the picture is on my end. But here on the WACC is 5 point, I don't remember.
Yes, 5.52, we can see it.
Yeah, exactly. And I took the long-term G of 3% and the growth equal to 3% as well. So they are exactly the same. So for this continuous value, when we did this equation here, we find 118. And by using this equation over here, we find also the same result because it's exactly the same equation. I on purposely did kind of like a mistake here because for this equation here, we can take can take this value, which is the free cash flow of year one, but not discounted because, sorry, I'm confusing everybody. Because here the result of 118 is not how do you put that? We need to discount this value here, which is 90, and then when we add up 90 and 11, we find the entire value of the free cash flow, which is what we want to do here, because since it's a constant G, then we don't have, we can just take whatever number of the free cash flow here, but it's easier to take the first one because we don't have to, we don't have to use the present value here. So we can find the exact same value over here. I don't know if if you all follow.
So if you were to try to put that in a very simple term, what would be the condition that would cause these two equations to equal the same value? Well, there you go.
The equation would be.
Oh, my question, Rick.
To have the constant G for the explicit period and the continuous period perfectly equal, the same. So in that case, it was 3%.
Okay. And Jaden, I knew I was stealing your question because I knew that you knew the answer to this because you've answered this question for us before. And I'd like you to have to think of another question. Okay. So there's a couple other things we might have to consider here. What else would you tell us, Martin?
That I cannot screw up that part. It was kind of confusing. No, but because when I did it, I wanted to, highlight that this part of the equation, I mean, this equation is exactly the same as this equation, but for this result of the value of free cash flow, we don't have to discount this free cash flow because it's already in year one. So it gives us the result directly.
Well, more specifically, we don't discount it not because it's in year one, but because the value that it creates is in year zero. Remember the equation there that you have in the upper right-hand corner for value FCF is value FCF at time 0 is equal to free cash flow at time 1 minus divided by WACC minus G. So it is already a present value, so we don't need to discount it if we're taking the very next cash flow.
Yeah.
Have you thought of one of the other relevant questions yet, Jaden?
Just the main, like, do you have any idea of a way you could algebraically show that this is true? So, specific, I guess is more of a comment, but like specifically looking at the T, if you rearrange this at all, would it give you the same equation?
Yeah. As a matter of fact, yes. However, we have to go ahead and run the algebraic proof for the Gordon growth model, which leads us to it is simply the sum of the free cash flows at times I divided by 1 plus WACC to the T when those cash flows at times I are growing at a constant rate. And then you run the proof of that, but that proof is truncated because it's a perpetual series of values. I mean, it's an infinite series of values we're playing with here, and it's a big proof. There's something else at play here, though. How realistic is it to make the assumption that the company's growth during a explicit period should be equal to its growth in perpetuity?
It's not really realistic.
How come?
I mean, 3% would be kind of like okay to say that the long-term growth would be 3%, but I mean, as an investor, I would try to expect a higher growth for the next 2-3 years. But so let's say 10%, but if we say 10%, 10%, then the long-term growth, if we want them to be equal, then 10% in the long-term growth is probably irrelevant and not really true.
So I think you're wise to, when you answer the question, to indicate under what conditions we like it and what conditions we don't like it. And so saying, all right, if they're going to be constant, then that means that the long term is going to equal the short term. And so we're going to increase the long term up to some larger number, and that loses plausibility, right? It's just not realistic. What about the other way around? What if the short term becomes equal to the long term? What would those conditions look like?
That you don't have much hope for the future?
Okay, so if we're in a dynamic industry, but our company's just not able to come up to it, then yeah, our management's got a problem, right, Megan? But there's another scenario here. What if you grow corn? You process corn, you sell corn for a living. That is your industry, your lot in life. Is corn a growth industry?
I don't know.
Well, is it a dynamic, popular, everybody wants to get into growing corn industry?
No.
Probably
No.
not.
In fact, it means you're a farmer, right? And farming, if you're going to get into farming, it's because it's in your blood. You love the land. You love being part of the food supply. It's not because it's a dynamic growth industry. You've got a passion for it that's coming from somewhere other than its dynamics in the marketplace. We would say that corn is commodified. A kernel of corn that I might grow in Kansas and a kernel of corn that I might grow in Oklahoma, when it gets to somebody's dinner table or the feed trough on a ranch, they're virtually indistinguishable. And to the extent that the corn or wheat or barley or any one of these staple crops becomes a growth industry is because we come up with a new use of it. Well, for corn, we came up with ethanol, and that changed some of the corn industry. But if it was wheat, well, wheat's wheat. Come on. You know, it makes bread or it goes into sprouts or, you know, some darn thing. And it's commodified. The expected growth rate in wheat is the expected growth rate of the population. And the expected growth rate of the population is correlated with the expected long-run growth rate of the economy. So these are going to become commodified industries. So it's plausible that we might have the short-term growth rate be equal to the long-term growth rate in an industry that's commodified, in which the companies that are there are already at optimal scale, that the products that are being produced and consumed are so readily available and so indistinguishable that that there's no competitive advantage, there's no monopoly advantage in this. So that's something to think about as well. Any other questions on this?
Could you go to that last slide just one more time so you can just see kind of how it all wrapped up?
That one?
Yes, thank you.
Okay.
And if you'll unshare, and I'm going to share my screen with you for just a second so I can show you something else with respect to this.
How do you unshare?
Well, that should tell you to stop sharing. There you go. And so now I'm going to share mine. And I will go to a spreadsheet. Again. Okay. So, you know, here we're back at Marijuana, value of 172,788. And I want to look and see what happens when we model this being the same. So if I take and turn our growth rate, long-term growth rate, and our forecast rate of sales into the same number, then I still come up with a present value of my discounted cash flow, a continuing value, present value of my continuing value, and a value, right? And in this case, it went down a little bit. It went to 157.9. That's because we don't have as much growth. And if there's not going to be as much growth, there's not going to be as much value in the entity, right? We've lost that dynamic. So I come up with valuing it in this formal way, 157.9. But here, notice how I've also come up with the same number. I simply am taking my cash flow at time 1 and dividing it by WACC minus G. So I'm using that Gordon growth construction. And in doing so, it gives me the exact same 157.91. So this one singular little equation has done everything that all of this did. When the growth rate of revenues, or in our case, the growth rate of the company, in the short run, our explicit period, is equal to the long run growth rate. So it's a very simplistic way of doing it. It's a very broad brushstroke that takes some wide assumptions into account, which assumptions may not be all that accurate. If we applied a good, robust growth rate to this, then this thing becomes crazy, right? When we apply a very nominal growth rate, it must be because either we're not managing the firm well, or it's not in a dynamic industry, or we're simply in a commodity industry. So if you're answering this question, you can answer it from the algebraic standpoint. You can talk about what it's like when they are the same, when they're not. You can talk about under what conditions they should be the same, or under what conditions they should absolutely not be the same. You got a lot of latitude within these questions. Does that make sense?
Yes.
A little bit, sort of. Okay, all right. We're gonna hope that your silence meant yes. Okay, so we're at a quarter till. We've gone through several of these. The next one up would be Megan. You're at question number 11, Megan. Let's see real quick. Yeah, I think we've got time that we can go through and explore question 11. Megan, before we reach 12 o'clock. Let's go ahead and do that.
Okay. Can you see my PowerPoint?
Yes.
So my question is number 11. Explain as much as you can about the CAPM equation and provide its illustrative graphic model. Be sure to include an explanation of each variable and each of the term's capital elements. So as we know, the CAPM is the capital asset pricing model. Also could be thought of as the opportunity cost of common equity. And in our WACC equation, it shows up as the return on equity. And then here's the basic equation form here. The parts of that equation, the RF is the risk-free market return. We often think of this as the same rate as the 10-year U.S. Treasury, because hopefully the U.S. government won't default, although who knows at this point.
Careful.
The return RM is the average market return for equity in the industry, which the firm we're talking about is in. So if you invested in that industry, you should expect to get this return. The beta here is the risk adjustment for the firm compared to the industry average for the firm, such that beta equals 1, indicates the firm's risk/volatility level and is equal to average firm in industry. So basically it's like, you know, how much above or below is your firm from the industry average. And the graphic illustration that shows this is here. We've got the market security line, we've got the risk on the market, the risk-free rate, and then, you know, you can see if your company is overvalued, it will be under the market security line, and if it's undervalued, it will be over the market security line. And then here's the beta. And that's it. Questions from Martin?
Can you just restate the security market line? It's just is it based out of the CAPM equation directly, or is it out just something else?
I think it's so the this line here is representing the market. And so if you were exactly on this line, you would be getting the return of the market in general.
Oh, okay.
So if you were just to invest in the whole market of that industry.
So Martin, as on the y-axis, where Megan's given us ERM, or the expected return of the market, if our company has how do I put this? So if our company's RE is equal to RM here, the expected RM, that means that we are valued similarly with all the other firms in the industry, and we have a similar risk pattern because we have a beta of 1, right?
Yeah, okay.
Okay. So Megan, go ahead and put your mouse a little bit above ERM, please.
Here?
That's good. So if our company has an RE that we could plot on this as well, that's greater than the expected RM, then it's going to be up here about where Megan's got her pointer, in which case if we come straight over to the right and intersect the SML that she's doing, then that helps us see as we come straight down that we also would have then a beta higher of 1, right? So, and Megan, I'm familiar with this graphic, and we have to think about what undervalue and overvalue means here. It means undervalued compared to the rest of the industry, not overvalued for the company itself, okay? So it's overvalued or undervalued compared to the industry that we're in. There may be a reason that our company's RE is meaningfully higher than the market RM, okay? And because of some of the dynamics happening within the company, which is reflected by the beta, right? And so we may not be overvalued in and of ourselves. We may just have a higher value than the industry has because there's a dynamic that's driving us there that maybe is superior to the rest of the industry. So you'll have to consider that.
So would that mean that the higher the return, the higher the risk also?
What do you think?
Well, then I would say from what we just saw with Megan's mouth, then the higher the return in equity you have, then the higher your beta is. But it's not necessarily a bad thing, right?
It's not necessarily a bad thing. That's right. That's right. I mean, you look at some of the most successful companies in the market, and they have a meaningfully higher beta factor than the average companies. Because you're right, that right along with cost of capital being synonymous with return of capital, you have risk being synonymous with reward. Okay, when you have one that's higher, the other is higher as well. And it's not necessarily a bad thing, it just is what it is. It may reflect, and if things work out well for the company, it's going to be a great thing for the investor. So I think the only other thing I might consider in answering this question is that the CAPM form of calculating RE is the best of our three options, or the best of our options when we're trying to calculate RE. The others would be inferior to it. The second one that we might consider would be the Modigliani and Miller theorems, correlate using the Gordon growth model, such that RE is equal to D1 divided by P0 plus G. So that you're going to remember when we did the good, better, best and thinking about the the WACC cost constructions. So you might talk about that. And you might talk about how this component goes into the WACC equation, because that's where we use this. Any other questions, guys? Okay, go ahead and stop sharing your screen, Megan. And I'll share mine again real quick. So we skipped over Jaden, of course. I'm going to move Jaden up to be first on Wednesday, and then we'll follow up with Micah, go on to Noah and such. I'm going to guess that we're not going to have Ada, so because she wasn't with us today, I don't think. And Ada, if you're there and I just haven't noticed you, please excuse me and kind of make yourself known to us. And then you're also going to find I won't spend the time going through some of the early elements we talked about that had nothing to do with this part of the discussion today, so we'll buy some time there. And then you're going to find, as some of these questions overlap, as I indicated they would, that some of you will end up getting fewer questions and comments back than some of the earlier ones. So we should have time in our 2 hours available on Wednesday to get through the rest of these without a problem.